Hello, Algebra 2 students. This is going to be a two-part lecture for section 4.8 on the quadratic formula. What I want to talk about first is kind of why we need the quadratic formula. That's going to be the first part, and then the second part is going to be actually utilizing the quadratic formula. So, revisit Algebra 1, the tasks that you guys generally had to do. We did a lot of solving equations that might look like this. Okay, and these are called linear equations because when you graph them, if this was not a 7, if this was a y and you graphed it, it would make a line. But all of the time when you had these linear equations, they were very straightforward to solve. All you had to do was get x by itself. Okay, so you would add 5 to both sides. You'd have 2x is equal to 12, and then x is equal to 6, and you are done. Now the problem with this is that when we are dealing with quadratic equations, remember, quadratic equations might look like 3x squared plus 4x minus 6 equals 0. When we are dealing with quadratic equations, you can't just get x by itself like you could here. There's multiple x's, and there's no really straightforward way to solve that. In fact, all we've been doing all chapter has been looking at different ways to solve that. We had factoring using the traditional method. We had factoring using the box method. We had solving using square roots. We've had completing the square. And we have all these different methods, but there are still problems that none of those methods work. None of those methods allow you to solve the quadratic. So this method, the quadratic formula, always works. It solves all quadratics. Why do we not just use the quadratic formula and forget all that stuff? Well, it's kind of a lot of work, and there's a lot of spots for mistakes. And sometimes factoring is just a really essential tool for you guys to use outside of trying to solve quadratics. So that's some of the reasons. Yes, this is the one that always works. There's going to be sections on your quizzes and tests where I just say solve using any method. If you pick the quadratic formula every time, that will always get you your right answer, provided you did all of the steps right. I want to show you this graphic, and I want to walk you through this graphic really quickly. So going back to this, when we had equations like this, linear equations, it was just one thing that you did to solve it. It was always just get x by itself. But with quadratics, we have a multitude of different ways to solve them. And this is just a graphic to help you decide which method is best. So remember, quadratics are written ax squared plus bx plus c. If the b term is 0, if it's just something like 3x squared plus, 18 equals 0, this is a problem where the b is 0. So then you can solve this using square roots. So right away, look to see if the b term is 0. If it is 0, solve it using square roots. If the b term is not 0, move on to the next thing. And then it's going to say if the a term is 1, use factoring. However, factoring will only work if your solution is rational. Okay? If your solution is imaginary or irrational, you would need to use completing the square. So if the a term is 1 and your solution is rational, factoring would work. If it is irrational or imaginary, you would find that factoring didn't work, and then you would try completing the square. If the b term is not 0 and the a term is not 1, then you would try solving this using the box method. I want to just kind of show you guys, these both refer to squares, boxes, kind of similar. People conflate these a lot. The box method is this guy. Okay, so solve it using the box method. Once again, this will only work if it's rational. If your solution is irrational or imaginary, then these methods would not work, and you would have to use like the quadratic formula here. However, if for whatever reason you were struggling, even if the a term was 1, you could still use the quadratic formula. Even if the b term was 0, you could still use the quadratic formula. The quadratic formula will always work. So let's just go through a bunch of different examples. We're just going to do these four. These are four different quadratics, and we're going to use four different methods to solve these particular quadratics. I'm not doing any right now that have a b term of 0. You'll notice the b term is negative 12, 22, 10, and negative 5. So we're kind of not doing any of those right now. But for this problem, the b term is not 0, and the a term is 1, right? There's no number here, so we know the a term is 1. So then, b term is not 0. The a term is 1, though, so we're going to try factoring. Now, if you wanted to, you could just go to completing the square, because completing the square will definitely work. But factoring works most of the time as long as our solution was rational. Remember, rational means it could be written as a fraction. So, this problem here, to solve something using factoring, the traditional factoring, right? You look at the last number and you list the factors of that last number, the factor pairs. We have 1 and 35. 2 is not a factor of 35. 3 is not a factor of 35. 4 is not, but 5 and 7 would be. There are no other factors of 35. And so you'd say, okay, do any of these factor pairs, could they get you to negative 12, and how would they? 1 and 35 never add or subtract to negative 12. But 5 and 7 could add or subtract to negative 12. In fact, if both negative 5 and if both of the numbers were negative, now they add to negative 12. So this problem here factors into x minus 5 and x minus 7. Now that isn't solving the problem. We're very close though. To solve it, you just say, hey, what makes this one 0? And that would be 5. And then you'd say, hey, what makes this one 0? And that would be 7, and those are your answers. So factoring was a pretty quick process. It worked pretty nicely. If factoring didn't work, the place that you would notice it is none of these factor pairs would get you to negative 12. Then you would have to try completing the square. Let's then move on to this one. The b term is not 0, so you can't use this. The a term is not 1. The a term in this problem is 3. So then you would have to use the a term is not 1, so then you would try using the box method. If the box method didn't work, you would have to use the quadratic formula, but guess what? The box method is going to work here. I'll show you how. The box method, you make this little box, and this term goes in the first box, 3a squared, and 7 goes in the last box. And you multiply these two numbers here, and you write that the product, which is 3 times 7 is 21. You write the product on the outside. Now you list the factors of 21. You would end up with 1 and 21, and 3 and 7, and that's it. And now you're going to look for which factor pair could add or subtract to the middle term, which is 22. So could 1 and 21 add to 22? They definitely could, right? If both of them were positive. Positive 1 and positive 21 does add to 22. So these two numbers go in the second and third box, and remember, the order doesn't matter. We'll put a 21a in that box and a 1a in this box. Then we do this weird little trick thing where we say, okay, what is the greatest common factor of the top two boxes? The greatest common factor of 3 and 21 is actually 3. The factors of 3 are 1 and 3. And we actually listed the factors of 21 over here. And the greatest one they have in common would be 3. And this one has 2 a's, and this one has 1. And so in common, they have 1a. And then you would do 3a times what is 3a squared. This is like a multiplication table. This times whatever goes here would need to be 3a squared, and that would just be a. 3a times what is 21a, that would be 7. And then a times whatever goes here would be 1a, that would just be 1. And as a check, we make sure that 7 times 1 is 7, and it is. And so our factors, the thing that's like in parentheses to get us to this step, would be a plus 7. We got that from there, and 3a plus 1. Now, once again, we have to look at what makes these 0. This one's pretty easy to figure out. It's negative 7, but this one is more difficult. If I want to know what makes this equal 0, just set it equal to 0 and find out. Solve for a. Subtract 1, 3a equals -1. Divide by 3, a equals -1/3. Those are my solutions. What I mean by solutions, of course, is I could take -7 and plug it in for a and a. I would have to put -7 in parentheses, and I should get 0 out. And that's true of 7 too. If I plug in 7 here and here, I should get 0 out, or 5. Next up, we have another problem where we have a b term, and our a term is 1. So we would try factoring this, just like we did here. It's not going to work. In order to factor it, this would have to be set equal to 0, so this would be a +8 here. So we would have, I'm just going to write it and I'll erase it in a second. 10w plus 8 equals 0. If we listed the factor pairs, we'd have 1 and 8 and 2 and 4. And none of these get you to 10. 1 and 8 can't, 2 and 4 can't, using addition and subtraction. So that tells you that it's not factorable. Let's not do that. I was trying to erase it. Let's erase that. Because it's not factorable, we're going to try completing the square. So how we complete the square is you have to pick the c term, if you recall. And you pick the c term to be half of the b term. Half of 10 would be 5, and then square that number, 25. So take half of the b term and square it. That would be adding 25. And if you do it to one side, you have to do it to the other. So on the right side over here, -8 plus 25 would be 17. And this left side is going to factor. And remember, it's called completing the square because this is always going to factor into something squared. What multiplies to 25 that adds to 10? It's going to be +5 and +5. 5 times 5 is 25. 5 plus 5 is 10. So we have w plus 5 squared is equal to 17. Now you're going to solve this. You're going to take the square root of both sides. So you'd have w plus 5 is equal to, taking the square root of both sides creates a plus or minus. So you have plus or minus root 17. And then we need w by itself, so we're going to subtract 5, and we would get w equals -5 plus or minus the square root of 17, and that would be our answer. We would try to simplify the square root of 17, but the square root of 17, obviously 17 is prime, so it doesn't have any perfect square factors, therefore it's my answer. All right, let's look at this last problem. The b term is not 0, so we don't go to the left side on that flow chart. The a term is not 1, so we don't go down here. We're actually going to end up going to the right one. And that would tell us to try using the box method. 3n squared would go in the first box. +1 would go in the last. It would multiply 3 times 1, and we would get 3. We list the factors of 3. That's just 1 and 3. And we're looking for how these factor pairs could get you to -5. And 1 and 3 never get you to -5. Right, using addition and subtraction. So that tells you that this problem is not factorable using this method, or it's not solvable using that method. So that tells you that this didn't work. You'd cross it out, you'd be like, okay, I have to try the quadratic formula. So how we actually use the quadratic formula is going to be in the next lecture. So find that one, and let's keep moving.